You're always with us in spirit. Oh my God, Katie.
Are we there?
So impatient.
I well guess.
Impatient. Hello, hey, wow, Federico's in Germany.
We have brown butter
Adam's
chocolate
making
chip cookies.
brown
That's
butter
really
chocolate chip cookies.
that's the story of the day right there.
Brandon's in an airport in Australia.
And
Checking in before he gets on
Federico
his
is
flight.
in Germany. Okay, so
Wait, you're flying Virgin, Brandon?
well, he's just going to Sydney and then Sydney to Salt Lake.
Oh, okay.
He's in Melbourne right now.
All right.
So yeah. Okay, here's my request for Katie's birthday. I realize it's not my birthday, and I shouldn't make any requests, but I do want some brown butter chocolate chip cookies.
Oh boy. Well, there you go, Adam.
And Virginia.
Australia. Virgin. How are those Virgin planes? I've never
Didn't they go bankrupt?
Maybe that was just Virgin Galactic.
Oh.
Or Virgin Records. One of the many Virgins. Yeah, I bet
there's
they're
72
good.
of them.
Oh, good. Yes. We need more Adam bakery items. And then Mike told me before we started that I needed to step up my baking game. I'm like, look, I cook the food, all right? You make the drinks, Adam bakes.
Oh yeah, I mean, I really would love that recipe though. I can make cookies. I'll try and make cookies, but they won't be anywhere near as good as Adam can make. No.
Well, I don't know. Have you ever baked anything other than
When I was a kid? When I was a kid, I got a Star Wars book, and you could make a Death Star cookie. It was basically a big sugar cookie. Yeah, and so me and my mom made this Death Star cookie. It was huge, and we drew the little circle, for the planet killer laser, and then we drew the lines across for the trenches. It was good.
Was that the last time you baked?
That was probably the last time I baked.
All right, are you ready to start the show?
Let's do this.
A countdown? And you don't like a countdown.
Well, it just makes me laugh. Mm-hmm. All right. Hi, everyone, and welcome to Cosmos with Cosmos. As always, I'm Mike,
I'm Liz,
and Brandon is in Melbourne, Australia. Mate,
but not anymore. That if you're listening to this in the future,
he hopefully is going to be in Salt
He'll
Lake
hopefully
when
be
you're
back home.
listening to this. Today, we are going to be talking about measuring the universe.
what?
Yeah, because, we've talked about... Oh, by the way, this is our 88th episode.
Hey,
Not counting shots. And there have been 31 shots that have been...
crazy 88s.
Yeah, so now I'm looking forward to episode 100. Happen later this year, maybe. But anyway, so we've talked about over these 87 previous episodes, including the shots, about all these, amazing things out in the universe. And I thought a couple weeks ago, or last week, it might be kind of fun to talk about just how we actually measure these things.
Yeah, because it's big distances, and we don't have tape measures that
No.
are long enough to get anywhere.
No, we don't. No, we don't. And so that's what we're going to be talking about today. And so it's a terrible outline. I'm just going to throw that out there.
Oh my gosh.
It got to a point where I'm like, I'm just not working on it anymore. I'm going to go enjoy my Sunday. But anyway, what you drinking?
Oh, I am drinking the Paloma effect because it is officially Paloma season.
It is officially. You got your first Paloma.
Yesterday.
Was it yesterday?
No, 2 days ago.
Friday.
Friday.
It was
Yes.
Friday.
And it's basically it is orange infused tequila, grapefruit juice, simple syrup or sugar or something, and Sprite.
All right. It is with lime juice.
With lime juice.
Yes, I had to think about for a second. Yeah, there's lime juice, sugar, to knock down some of that tartness, grapefruit juice, and you're supposed to infuse just regular tequila with oranges.
But we infused orange infused.
Yeah, we got
already
orange tequila, so it
infused
probably
tequila.
has
It's double orange.
a nice little orange. Orange
I could
taste.
actually use a little bit more grapefruit actually.
Okay.
Because I do
that's
like
good
the
to know.
grapefruit.
It's good to know. And the Sprite is supposed to sit on top, but I don't think I've seen anybody actually drink it that way. So
Well, we like to mix it in.
it does. When you do pour the Sprite on top, just enjoy the gradient for a
Yes, it
moment.
has a nice ombre.
Yeah, it goes from this beautiful kind of pinkish to a real kind of clear with a hint of pink on it, and so it's really kind of nice.
Well, what are you drinking?
I am drinking what I am calling the Zeman effect. And
Oh,
you thought I was kidding? It's in the notes.
I didn't.
Did I say the Zeman effect? It's actually I left the effect off. It's the Zeman.
Oh,
Zeman.
okay.
But basically, this is what is this? This is peach vodka with bourbon with simple syrup, and you're supposed to add lemonade. But I was like, I'm going to do strawberry lemonade for this one, and it's not bad.
Ooh, I like the strawberry bourbon and the vodka. I gotta taste this.
Yeah, and it's and this is actually supposed to be the stronger drink because I added.
It actually has a nice gradient at the bottom. I can't really see it on camera, but it goes from like, it just goes to like clear at the bottom, which is kind of an interesting.
Yeah.
Anyway.
And so it's supposed to be more of a pink, peach color, but I have yet to find a lemonade that will give me that peach color.
Maybe a yellow lemonade.
Mm-hmm.
Let's see. Jack has pistachio and mint cocoa on a windy day. Oh, that sounds good. And in honor of the last Picard, of course, Mom has Earl Grey tea, hot.
Yes, but is this the last time she's going to have it?
Well,
That's
no,
her
of course
traditional
not. No,
podcast
that's
drink.
her. Yeah, she's.
Yeah. So, I've never had Earl Grey.
You're not really a big hot tea person.
I'm not a
Or
hot tea
cold
drinker.
tea person.
Because I'm Southern originally.
Yeah, originally.
Now I'm Pacific Northwest and loving it. All right, so follow us on all the things. Twitter, drinking Cosmos on Twitter, Cosmos on everything else like Instagram and everything like that. Follow us and rate us on all the things, iTunes and to Spotify. Please definitely follow us on Spotify and tell your friends to follow us on Spotify. Apparently, whether they listen to it or not, it doesn't matter. It's all about followers.
That is the culture nowadays. All about followers.
It's all about the followers. Whether or not you listen is meaningless. All right, so, and also don't forget to join us in The Hangover. Last week was very political. Who knows what's going to happen this week? So I'll try to tone down the politics, but it probably won't happen. Anyway, we also have a lot of people that you should check out as well. Wildixia on Etsy. Wildixia. That is Katie. She's got some amazing art that is there for you to enjoy, and more importantly, to buy from her. You can check out Ron Proctor at the Mr. Proctor Show. He does a lot of great stuff with, talking about. Well, he talks about politics as well, but also, education, from formal education to informal education. Speaking of informal education and planetariums, check out Jack at rollingbluffsplanetarium.com. So if you are in the Council Bluffs, Iowa area, definitely go check Jack out and let him show you the wonders of the universe in his dome. And if you're not in the Council Bluffs, Iowa area, go there for one thing, but also support your local planetarium and visit them. They definitely need the money, and they are some of the most passionate people that you'll ever meet. And also M42 Creative. I got nothing else to say about them. So that's us. So that's why. I don't know why I just didn't think until the 88th episode to say M42 Creative.
Well, because people don't usually promote themselves.
No, but I am. All right, so...
Other than the whole beginning where we're like, follow us.
Yeah. Also, definitely check out The Shot. We have some till June, right? Isn't that what you said? So we need to make some more.
Sure.
They come out every other Wednesday. Mm-hmm. There's one coming out this Wednesday.
Hold on, let me check a handy-dandy calendar on my handy-dandy technological device that's more powerful than people landing on the moon the first time. We have a Shot episode coming out. What day is today? We have a Shot episode coming out on Wednesday, May 3rd. So if you're listening to this on the podcast when it comes out, then it already came out. So check it out.
Yeah. And that's really, the Shot is where we take little small, bite-sized, drink-size shot morsels of
shots of science, shots of
science and history and astronomy and all that kind of great stuff. And of course, as always, if we have some rules that we all must follow, otherwise society breaks down.
Well, too late for that.
If a puppy barks, who knows if they will or not? They appear to be downstairs or something. But anyway, if they bark, then go ahead and take a drink. If there's a Star Wars reference or a Lord of the Rings reference, always please take a drink. With whatever you got.
Yeah, you don't have to be drinking alcohol, which obviously most people don't on a Sunday afternoon.
You don't have to be functional alcoholics like us. All right, so let's go ahead and let's dive into this. Let's get started.
Yeah, measuring space. We know how far away stuff is in space, which seems impossible because things are so far away in space. Everything is far away. Even just measuring how big the Earth is seems like a daunting task, and the Greeks did it.
Yeah, and that was just two sticks in the ground.
Yeah.
And they were actually pretty accurate with it, too. And they actually figured out the Earth was round, which they knew beforehand, and not flat like some of these crazy ass
no one
people.
ever thought that Earth was flat. Okay, people. Otherwise, they wouldn't have gone sailing out
too far.
They wouldn't have. Yeah. Anyway.
So this is what I was thinking with this was also, yes, measuring how far things are, but also talking about how we actually measure what something's made out of.
Oh.
That type of thing.
That is a measurement, isn't it?
It is a measurement, yeah. But first, we must understand what we receive from these objects, because the only thing we receive is light. That's all we receive.
That's it. Light is data. Light is information.
Yeah, and so, and in fact, actually has a lot of information in it. But when we look out into the universe, that's all we see. And in fact, when you don't have to go out to the universe. for me, experiencing this room that I am to this podcast is all... I'm receiving light information from everything that tells me that I have a monitor in front of me that has these little strange little symbols on it that we call letters and words.
Is that what those are?
Yeah, and across the room from me, there's a picture of where Liz and her family used to live and all of that. And so I am experiencing everything through photons, and I am quote unquote touching your hand right now. The reality is that I'm not actually touching you.
So really, when kids do that, I'm not touching you. They can just be touching and be I'm not touching you. I'm not. But we perceive the touch, so therefore it's touching. So don't touch anyone without their consent.
Yes, I know, right?
Don't touch anyone.
So we experience the universe through photons. And when we touch things, it's virtual photons that we are.
It's virtual photons.
Well, they're force carrying photons that we are experiencing.
The force carrying is it?
Photons.
It's the force.
Yeah.
Photons are the force.
Photons carry the force for the electromagnetic force.
Photons are the force, everybody.
Shit.
We've solved it. Photons. May the photon force be with you.
We solved it. It was solved so long ago.
We solved Star Wars.
We did. But yeah, anyway, so I think we should start off. What is light?
What is light?
Yeah.
Baby, don't blind me. Don't blind me no more.
All right, so there's the visible light that we all enjoy. From red, orange, yellow, green, blue, indigo, and violet. Yes, the rainbow.
Everybody experiences the rainbow. But
some of us like it more than others, apparently. But there's a lot of light that we can't see. And so we're just going to kind of, I say quickly, it won't be quickly, but we're going to step through these invisible
light
forms of light. Ooh. Yes. We're going to begin with infrared. So these, we're going to go with a little bit of a longer wavelength than red. And so when you look at the visible wavelength, red has the longer wavelength, and then the wavelengths slowly get shorter until you get to violet, which is the shortest wavelength of light, of visible light. And so I don't know why my tummy decided to...
No one could hear it. No one could hear it but me.
So let's start with infrared, which is a little bit longer wavelength than red, discovered by accident in 1800 by one William Herschel.
Brandon's favorite guy. He's probably on the plane already now.
Who Brandon really likes. William Herschel was...
hold on, what Frederico said. Do not perturbate anyone in electrons
without consent.
Yeah.
I mean, those electrons really push back on you.
Yeah. Stay away from
electrons. Are like, nope. We don't want to bond.
Talk to the electrons.
Yes. And so it was discovered by accident. He was measuring the temperatures of light.
And he was like, wait a minute,
why did the temperature go up a little bit when I don't have any color? And so he went a little bit to the side of red.
And he didn't go with ghosts?
He did not say it was ghosts, no. Okay. And so he discovered infrared.
I know, that's wild.
Completely by accident. There's 3 types of infrared.
Ooh.
Near, mid, and far.
Okay.
So near is closer to the red, far is...
Further from the
red,
so
closer to
wavelength?
The longer wavelengths.
Longer wavelengths.
Yeah, so the near is going to have the shorter, mid's going to be a little bit longer, and the far is going to have even longer wavelengths. And basically, infrared allows you to see objects that are too cool and faint to be seen with visible wavelengths, and so... you can find brown dwarfs this way and things like that. It's what James Webb
really
likes to use.
Distant, cooler old galaxies.
Yeah. And what's really great about infrared is that these longer wavelengths pass through denser dust and gas, whereas with less absorption and scattering than visible light. And so you're able to see through the dust and gas. So if you have a big cloud of dust and gas, like a stellar nursery, you can use the infrared to see the baby stars that are in the cocoons.
The cocoon that we normally wouldn't. I mean, it's like, I mean, I know we're gonna get to X-ray, but it's like X-ray, but it's like not
It
X-ray.
really is kind of real X-ray.
Infrared vision.
Yeah, and so we use it to study the universe that we live in, the larger universe.
I see things at night better.
Yeah, and night vision goggles use infrared, and that's really cool. Yeah, that's actually is really cool. The eyes look
But then
crazy.
there's animals and stuff that do see infrared.
Yeah, snakes. Don't snakes? Snakes, maybe?
I don't know.
Yeah, snakes
Yes?
do, because they see they're looking for the heat of things.
Oh, that's right. They're prey.
Yeah, and so snakes will see it.
They're cold, so
Yeah.
they see the heat.
But we don't always use it to look out into the universe. We sometimes use it to study the Earth, and so we've used it to study changes in temperature of the sea and the land.
Oh, okay.
And so it's really good empirical evidence
For climate change.
to show that the climate is changing, that the Earth is warming up, and all the naysayers can cherry pick it all they want, but it still shows that the temperature is rising.
It's going up.
If we increase the wavelength a little bit more, we come to this thing that we all have in our kitchens, a microwave.
Microwave.
Yes, the microwave wavelength, which is technically kind of the high end of radio waves. But they actually now consider it different because the technology they use to measure radio waves versus microwaves is different. And so, but microwaves, there are different bands of microwaves, just like there are different parts of the infrared. You have medium length C-band, which can penetrate clouds, dust, smoke, snow, and rain to reveal the Earth's surface.
Oh, what one do we use to cook with?
Oh, that's a good question. Actually, I don't know.
Oh.
But what it does is the microwave oven. What it does is so the microwaves it forces the water molecules and the fat molecules to rotate, and
that heats it up.
And that heats it up.
Oh.
That
and that's
force.
why there's that mesh screen on the front of all microwaves, because those holes are just small enough that the microwaves can't get through them to cause any harm to
To
those
us.
that are just watching their food cook.
I remember when I was a kid that when I thought microwaves first came out, but apparently they didn't. But my mom was like, "You're gonna get radiated if
I was
you
told
just
not
watch
to
your food.
get
Don't
too
don't
close
watch
to
your
the-
food. Don't."
That and the TV.
Yeah.
The TV hurts your eyes. Bad
So-
for your eyes. Sit too close to TV.
So that's the C-band. That's the medium length C-band. There's also the L-band microwaves, which is used by GPS. The reason why they want to use the GPS is the L band is because it can penetrate the canopy of forest. So your trees aren't really affected by it. Don't affect it too much, and it allows them to measure soil moisture in rainforest. So that's kind of cool.
Oh, that's interesting. I didn't know microwaves were used for so many things.
Yeah, actually quite a bit. And communication satellites use the C, X, and KU band to send signals down
I never
to
thought about what kind of light GPS uses.
That's true. I never thought about it either until I started putting this
how it
together.
just send. I mean, I just thought
They just send a signal.
Send a signal. So I never thought about what that signal actually is.
Right, but it's it's important because you can't send the higher frequency signals are going to be blocked by the atmosphere, and so you want that lower frequency, but you also want to pick something that that you can obviously penetrate clouds and dust and gas and all that kind of stuff, but also apparently canopy of trees.
That's cool.
Which I never thought about.
Well, I mean, the rainforest where we're not destroying it is thick and dense, and so.
And you see it if you have regular TV, or you have a weather app, and the news or your weather app has Doppler radar, that is actually using microwaves.
Oh.
Because radar is actually radar can either be radio waves or it can be microwaves, but Doppler radar uses microwaves.
Oh, okay.
And of course, you can't talk about microwaves without talking about the Big Friggin' Bang.
The cosmic microwave
Background radiation. So, if you go back to the 1960s, Arno and Penzias, they discovered this microwave radiation that was coming from all parts of the sky. They thought it was bird poop. All this other stuff, and they discovered the afterglow of the Big Bang. All right, so what do we got here? You can measure the length of your microwave cooking a chocolate bar and look parts
that melt and the ones that not when it's not a rotating plate.
Do they even make them not rotating anymore?
I'm sure they do, yeah.
So.
But yeah, that is that's cool to see. It is. I mean, it's fun to watch food cook in the microwave.
But you shouldn't do it. You're gonna end up being like the Hulk.
And you got,
but in a weird way, because
microwaves cook in the universe, and microwaves cooking your food.
All right, radio waves.
That was a very Tyson voice you just did.
Oh, was it?
Yeah, it sounded very Tyson.
I cannot reproduce it.
Okay.
So. All right, radio waves. These typically had the wavelength from the size of a football to larger than the Earth. So I thought radio waves. To me, radio waves. All right, so the most famous radio wave is 21 centimeters, which is the radio is the wavelength of the light that neutral hydrogen will radiate at, and so you can use it to.
How do we measure how long?
It's all based in quantum physics, and so with quantum physics, you can actually determine the length of the light, the wavelength of the light. That will be created when an electron jumps from one shell to another shell, and from one energy level to another. And so it's all based in quantum physics. And so 21 centimeters neutral hydrogen, and you can use it to actually map out clouds of dust and gas, and from that you can get the spiral shape of our galaxy. And that was using 21 centimeters was how we were able to figure out, at least initially,
that our galaxy.
Yep. You have some like observational where you look out into you look into your telescope and you see other spiral galaxies and you see their shape and you're like,
so
okay, the Milky Way kind of has that same appearance, and so we're probably in a spiral galaxy, but mapping out clouds of dust and gas really shows you that spiral shape, and then really kind of proves it, other than us just saying we think we live in a spiral galaxy. But it was proven to exist. Radio waves were proven to exist by Heinrich Hertz in the late 1880s. Yep. And so he had a spark gap apparatus, and he was able to prove that radio waves actually existed in the 1880s.
What is a spark gap apparatus?
I'm not entirely sure.
Okay.
But I think what I think it's two plates. And these plates are charged, and they'll make a spark. But I believe that's what it is. So he had a set of two of them, and so he had a spark here, and it induced something over here in this other spark plate that he had, the spark gap. So the gap is your two plates, the gaps between them.
Okay.
It's like basically you make little lightning bolts out of them, so which is fun.
Which is fun. It's fun to make little lightning bolts, I mean, I would just want it to make little lightning bolts.
I know, right? So you would just constantly
science with
zip,
it.
Zip,
And
zip.
I'd be like, ooh.
But in 1932, Carl Jansky proved that objects in the solar system actually emit radio waves.
Oh.
Yeah, so you can use it to view planets and comets and giant clouds of gas, which we've talked about, and dust and stars and galaxies, and probably the most famous galaxies. The ones that you see shortly after the Big Bang, quasars.
Ooh, quasi-stellar...
Radio source. Yeah, radio source. And so they discovered those quasars, and basically they're really bright in the radio waves. And so you need really big telescopes to see these things. So if you are ever in like the Las Cruces area of New Mexico, the very large array, in the United States, they have a whole set of these telescopes. They're seen in the movie Contact. Is what Ellie is sitting on the hood of her car, listening to. You don't freaking listen to those things.
No, you can't. Let's get the baseball game on that radio. Is it AM or FM?
It's really far.
So the quasars are in AM. So really, it's just
it's
church
really
talk
far.
radio is what they're broadcasting.
Yep. The really cool thing about these radio telescopes, though, is that you can use interferometry with them, and so you can have one telescope in one side of the Earth, let's say Hawaii, and then you can have one in Italy, and they're all looking at the same objects, and you tie those two together, and you've basically you've made a telescope that big. And of course, the bigger the telescope, the better. And so it's really, really cool. Are all forms of radio waves okay? All right. Well, all right. Let's address this. This is actually kind of important.
Yes.
So radio waves don't carry sound, but what they do is they carry. They have a wavelength. They have a frequency, and they have in that wavelength, in that frequency is information. And they hit your antenna of your car. It goes into the radio, and then the radio converts that radio wave into a mechanical wave, for lack of a better word. It basically vibrates your speakers, and that is what makes the sound. And so the radio wave is not carrying sound per se.
We have to make the sound.
We have to make the sound out of the information that the radio wave is carrying.
It's kind of like streaming in a way, because you're not. It's basically your TV or your Xbox or whatever, your device is basically just getting all this little information packets of data that it's not. And that it then has to convert to a picture, then combine together into
a picture and sound.
It has to make a picture and sound out of just these packets of data that it's being sent, that it's receiving from a source, and it has to make. It has to interpret that and then convert it into something we see and hear.
Yeah, and so basically, what your radio does is it converts electromagnetic energy, light, radio waves, into mechanical energy, which is sound, which is what allows you to hear it. So
that's wild. I mean, it's just wild. It's just wild.
What is it?
It's wild.
It's wild. All right, so those are the longer wavelengths of light. Let's look at the shorter wavelengths of light. So let's go shorter than violet. Ultraviolet.
Ultraviolet.
Yes, ultraviolet. Discovered in 1801 by John Ritter, who exposed photographic paper to light beyond violet. So what he did was he knew that so there's no sound in space, but no one hears you scream in space. No one hears you scream in space. So in the 1800s, they knew that photographic paper could turn black the more blue light that hit it. And so what he did was he threw basically a spectrum up on the wall and put the photographic plate paper not in violet, but to the side of violet, and what would be the ultraviolet part, and turned black. And so he proved there was ultraviolet light.
And he didn't go with ghosts either.
He didn't go with ghosts either, because we don't do that. We didn't do that back then. I mean, some of us did.
But in the 1800s, everything was ghosts.
That's true. That's true.
Actually, now everything is 1800s ghosts.
All right, so when you take an ultraviolet picture, and by the way, you need special technology for the light that we can't see, right?
Right.
And
you
so,
can just, yeah.
Yeah, and so you prove it's there, but then you need to invent the technology to actually
see it, basically.
Basically to make an image of it. But when you take an ultraviolet image of galaxies, it shows clouds of dust and gas that have newly formed stars in them, because they will be. You're going to have a lot of brighter, hotter stars, and they're going to be brighter in the ultraviolet light. And so you're able to see that. You can actually take pictures of the sun in ultraviolet, and see where all the storms are on the sun and that type of thing.
Go to the was it the SDO, Solar Dynamics Observatory website, and you can look at what the sun looks like right now, right this very second.
Yeah.
And you can also see it in different wavelengths of light and see how different it looks and the kind of different features you can see on the air quote surface.
Yeah, and so what's really cool is if you look at a galaxy in visible light, it shows you where a lot of the older yellow and orange stars are, and if you look at the same galaxy in the ultraviolet, it shows you where a lot of the younger stars are. And this next thing I thought was really cool. I did not know this, but the Lyman Alpha Mapping Project (LAMP) on board the Lunar Reconnaissance Orbiter (LRO), which is go work out, which is orbiting the moon. This is really cool. Can peer into permanently shaded craters on the moon, like at the poles, and can actually sense faint reflections of UV light coming from distant stars. Basically, uses them as a reflector.
Oh,
that is so fucking cool. I just think that is the coolest thing.
That's wild. Okay, that's the word of the day. Wild.
Yes, that is insane. So, all right, continuing on, because I'm going long.
Yeah, we haven't even got to measuring anything.
Yeah, X-rays discovered in 1895 by Wilhelm Conrad Roentgen,
and commonly known for when you need to go to the doctor or the dentist.
Yeah, and so these show you extremely energetic events in the universe, and so short wavelengths
and the bones in your body.
Yeah, and that was it. This is actually a form of light that did go really quick from discovering to practical use.
Oh.
Yeah, with X-rays and stuff like that.
How long did it take before they figured out that you need to have that heavy thing on you, or else it will just X-rays will destroy you?
Probably took a while.
Okay.
Probably took a while.
A lot of people got some X-ray cancer.
And X-rays come from objects that are millions of degrees in temperature. So you can use it to...
I guess you could say it's getting hot out here.
Yeah. Corona, use it to look at the corona of the sun and things like that. Spirit, use it to look at X-rays from X-ray signatures coming from zinc and nickel in Martian rocks.
Oh, Spirit had like a device that could utilize X-ray? Oh,
yeah.
Neat.
And then you have gamma rays. And these are produced by the hottest and most energetic objects in the universe.
Yeah, that shit'll kill you real fast.
Yeah, neutron stars, pulsars, supernova explosions, and regions around black holes. So accretion disks. That is and here on Earth, nuclear explosions will create a lot of gamma rays.
A little gamma.
Yep, lightning creates a lot of gamma rays.
Oh, really? It doesn't just fry you. It also gammas you.
Yeah, and also gamma you. Gamma you.
A lightning Hulk.
So what's really cool about gamma rays is gamma ray. All right, so X-rays have a wavelength that is at least on the short side of wavelength of X-rays, about the size of an atom.
Okay.
Gamma rays obviously are shorter. It actually can go through the spaces between atoms, and so building a detector is quite hard. And so what they've done is they have created really dense crystals to detect gamma rays. And what it happens is the gamma ray comes in, it knocks off an electron. The electron moves off in a direction. The gamma ray actually loses some energy. You can detect the moving electron. You might actually even be able to detect the now reduced energy gamma ray, and it's actually called the Compton effect, but which is actually what I should name my drink. But anyway, it's Compton scattering, and that's how they kind of discover these gamma rays now. So,
all right,
and so those are the forms of light. Now let's get into what they tell us. All right, so with them, you actually can tell a lot about an object.
Well, I should hope so, because
that's all we got.
It's pretty much all the data we have.
Yeah.
So that's all we can.
And I think probably the main thing that the important thing that you can tell is what something is made out of.
Oh.
Yeah, and so when we look at a rainbow, it's just a beautiful gradient from red to violet, right? And
everybody gets mesmerized, especially if there's two of them. People freak out when there's a double rainbow.
yeah, and those actually are kind of cool to actually see. So, however, though, if you were to take a telescope, if you were to shine a rainbow onto your wall, and then you would take a telescope, microscope, whatever you want to call it, and you would really finely look at the rainbow and zoom in really close, you could see little black lines in the rainbow.
You don't need a special thing to see the absorption spectrum?
No, I think the initially the absorption was somebody just took a real close look at it. They basically zoomed in on it and they were able to see it. And these little black lines. And now you do have like specialized equipment that actually will show you the absorption lines of an object. You can even take pictures of it and that type of thing. So, but I think originally the very first time was somebody actually just took a damn closer look at it.
Okay.
And so these little black lines in a rainbow continuum are called absorption lines. And what is going on with absorption lines is that as the light comes through either the outer atmospheres of a star or through our atmosphere or whatever, the elements that are in, say, our atmosphere will absorb some of the wavelengths of that light, and it creates these little black lines in what would normally be a continuous spectrum rainbow. What's really awesome, though, is that these little black lines, they are the fingerprints of elements. And so
no single element has the same exact
absorption lines.
Spectra.
No, because they all have different electron configurations. They all have different energy levels and things like that. And so they don't share the same fingerprint. These are the fingerprints of objects. Of the universe, really, of the elements.
That was one of my favorite labs in my astronomy class. In college was we did a lab on absorption and emission spectra, and we had to do a little did you Davison and spill?
Davison.
He did it. He spilled, everybody.
Well,
we have a Davison over here.
I got it on the iPad.
But we had to then figure out what elements were what based on the fingerprints that we were seeing, based on the absorption spectra or the emission spectra that we were seeing, which was really fun. We had like these tubes filled with elemental gas, basically.
Yeah.
And there was various different ones and whatnot, and it was really fun and really cool to see because you don't think about.
Yeah, well, you're probably seeing
that.
You were seeing the emission line, right?
I think we did one with both. We had two different. We had like a special set of glasses for one, and then it did something else for another one, I think. But
well, this is a great story about absorption lines.
Oh,
and
okay.
I love it. We've done a shot.
What's the title of this story?
Woman says "fuck you" to the patriarchy.
Woman says "fuck you" to the patriarchy.
Yeah. So in
a story on absorption spectra.
Yeah. So in the early 1900s, most astronomers thought that iron was actually the most common element in the sun's atmosphere.
Oh.
Yeah.
Well, let's hope not.
And actually, that hydrogen played a very minor role in the atmosphere. We have a fly.
There's a
big
here. Fly in here.
The person who solved this and said, "No, all you people are wrong," was one Cecilia Payne.
Oh, we did.
We did a shot.
Yeah, check out the shot on Cecilia Payne.
Yep. She actually solved the puzzle and figured out the true composition of stars. Cecilia Payne, and she figured out it was mainly hydrogen and helium and not iron. There's really not a lot of iron in the atmosphere.
Let's hope not.
No.
If our son had a lot of iron, big bada boom coming. That's not good.
Um,
Oh. Hold on. We got I stole all my dad's remotes.
This one don't work.
all he wants to do is work out.
That was a cameo from voice cameo from Podcast Dad.
Yep. That's funny. All right, so whereas absorption lines will make little black lines in the spectrum, you actually have what are called emission lines, and these are very bright lines on a black background.
Yes.
And
yes.
so these are emission lines are where you have like a big cloud of dust and gas that is emitting light, and each element is going to emit a light in certain wavelengths, and so you get these very bright lights, bright lines. And actually, if you were to take an absorption line, say of hydrogen, and an emission line of hydrogen, and you put them together, they actually make a continuous rainbow. Yeah, and so the emission lines fill in the gaps of the absorption lines, and so with absorption lines, you can figure out the composition of a star's outer atmosphere or a cloud of dust and gas, as you have this this continuous spectrum come through and gets absorbed. But if those things are actually glowing themselves, and you get emission lines, and you're able to figure out. So we can use these to really kind of figure out what things are made of.
Measuring what they're made of, and then how much of something.
Yeah, and exactly. And so the more, say, methane you have in an atmosphere, the bigger that line is going to be, the stronger it is. And so you're able to say, and Webb is going to be able to do this with atmospheres and say, it's got a lot of friggin' methane in it, which means
we got a lot of cows over here farting in space.
Yeah, exactly. Or some tectonic stuff that's going on. But, you can use it to... I mean, methane is really important because methane doesn't stick around. Ultraviolet light will destroy it pretty quickly, relatively speaking. And so if you
have a continuous supply of a lot of methane, then something's producing that methane.
Yep. And life... really good at
finds
producing.
A way.
Life finds a way to produce methane.
Life farts away.
All right, so you named your drink the Paloma Effect.
Yes, I did.
You added so you had effect in your name. It made me
I was not paying
subconsciously.
attention to
Well,
the name of
mine doesn't. Mine just says the Zaman.
Yeah, and you would think, but my brain would have been like, oh, it's.
Well, not necessarily.
I didn't make the connection. So basically, our drinks are named after the same thing.
Yeah, which as it should be.
As it should be. Hold on, I gotta refill my drink, which I know you hate. You hate so much. But it has such a nice. I'm not doing it by the mic. Alright.
I mean, it is. People know that we're
Drink
drinking,
refill sequence complete.
Yes.
Resume podcast.
All right. There is this thing called the Zaman effect. And
is it Zaman?
Yeah.
You got the pronunciation?
Yeah, he's Dutch.
Oh, okay, because it's spelled Z-Man.
Yeah, it is spelled Zeman, but it is Zaman.
Yes.
And so he was this Dutch dude, Peter.
This is Peter.
Peter Zaman. In 1896, he discovered the effect named after him. And basically, if you look at these, what he was finding was, if you look at these absorption lines and or the spectral lines, I should say, because it doesn't really matter. The spectral lines, he was seeing that there were two little lines where there really should just be one. And what happens is the magnetic field splits those lines. Yeah, and the stronger the magnetic field, the bigger the split.
Oh, but we don't know how magnets work.
Jesus. And so he discovered what is now named after him, the Zaman effect, which is that you can actually measure the magnetic field of something by looking at the light.
At the light.
Yeah, because it'll split it'll split the the absorption lines. Interestingly enough, you also have a similar effect called the Stark effect, named
Stark?
after Tony. It's not named after Tony, but it is the Stark effect, which will tell you about electric fields. And it's a little bit different, but you can tell the difference between the two. And so he won the Nobel Prize in 1902 for his discovery in 1896. He won the second Nobel Prize.
The second ever Nobel Prize?
Yeah,
That's
I think,
cool.
and Hertz got the first one.
Hertz got the first one.
In 1901.
Look at that.
Yeah. And so, yeah, the strength of that magnetic field is the distance between the lines.
That's cool.
Yeah. You can also tell the temperature of an object by looking at its in the stars, really in particular. You can tell the temperature of them by looking
You
at
maybe
their...
don't have just have like a thermometer that points out, a thermometer telescope that points. Just
that
takes
actually-
a reading.
That'd actually be really cool. But
Under your armpit.
so yeah, and so if you look at the light curve, like how many photons you receive of each wavelength, it makes this beautiful little curve that Max Planck discovered in the early 1900s, and the maximum of that curve tells you exactly how hot that star is.
Wow.
Yeah, it's called Wien's displacement, and it will give you the wavelength and the temperature. And so you look at it, you know the wavelength because you've just measured it, and then you can get the temperature from it. And so and vice versa. So if you know the temperature of our sun, it tells you what the wavelength that is mainly emitted by the sun, which is in the color green.
Well, that's right.
Yep. Remember though, colors are
not what you think they are.
They're not. Colors are not real. Colors are our brain.
Are a lie.
They are our brain interpreting wavelengths and frequencies.
So then, can you ever really have a favorite color? Because it's just all made up.
You can have a favorite wavelength or
you
frequency.
You can have a favorite wavelength or frequency.
Yes, and so my favorite frequency is purple.
Like a hat.
Yeah. And also, you can tell how fast something is moving towards you or away from you.
It's funny then how we use red to symbolize something hot and blue to symbolize something cold when it's the opposite. In reality of...
You know, I was thinking about that yesterday, though. I had gone outside and was enjoying the just shade. I didn't want to sit in the sun. Because I like to be in the shade, but I was thinking about the podcast, and I was thinking about how with temperature we associate red, and I don't know why we do that, and so I came up with a hypothesis.
Oh,
and
you have a hypothesis.
This might be
I'm
true.
I'm sure you could have Googled it. I'm sure there's something on Google.
Yeah, and I'm sure. But when we sit by a fire, the fires are red, and we get the warmth and all that kind of stuff, and so we associate those with warm temperatures.
But the hotter fire is blue.
Yeah, but you usually don't have the energy to do that.
To make blue fire at a campfire.
Yeah, and so, but also...
yeah, Mom, it's not really gray.
But when we look at ice, you know, you can get a blue tint in the ice,
Yeah.
you know, especially if there's a lot of ice.
Yeah.
Like you look at icebergs, you can
Yeah.
get kind of a bluish tint in them. And so I think that's why we associate it with cold, even though it is the opposite. Blue stars are hotter than red stars.
Yeah.
So
That's interesting.
you know, it's probably maybe it's my hypothesis. I probably Googled it a long time ago, and it subconsciously is what it is. But that's just what I think. So now we can get. Why are you yawning? Is this boring to you?
No, I'm just tired.
All right, so now we can get into how big the universe is.
Oh God.
It's huge.
Oh God.
And how we figure out
All right, so
how big things
so
are.
as a mini recap here, we can use light. Light is data, and we use it to measure, you know, how what stuff is made out of, how hot it is, and now we need to use it to figure out how far away shit is.
Yeah. So there's a lot of information you can get from light. It's got a lot of information in it. So how big the universe is?
We'd be in the dark.
Okay. I throw this in there because now we really are talking about what are called standard candles in astronomy.
Well, my mom makes a good point. Our skin turns red when we burn it. And I burnt my skin the other day, and I have a little red mark. So, yeah, red hot.
Yeah. And
the candy, red hots.
Exactly.
They should be blue hots.
Oh, they should.
Anyway,
yeah.
All right,
but cinnamon's red, right?
Cinnamon is red.
Even though it's brown. Brown,
it's
but,
brown in
but
reality.
it's always red.
Yeah.
Is that a marketing thing?
Yeah.
That's a marketing thing.
Yeah. Anyway, moving on.
All right, so I include this first one. This first one really has nothing to do with light.
Oh.
Parallax.
Oh.
Yeah, and so when you are on the Earth, let's say you're looking at a star.
Okay.
You look at it on January
Which one?
1st.
Beyonce, Zendaya.
Sure. Whichever one works for you. And you look at a star and you measure where that star is against the more distant, further background stars.
Okay.
And you put it on a little piece of paper and you draw your little picture.
How do you know what are the more distant background stars?
Good question.
Okay.
But you take a picture of it.
Okay.
And then you come back 6 months later because you're on the opposite side of the sun from where you were 6 months later.
Okay.
And you take a picture of the same star, you see that it has shifted against those more distant background stars. I guess you can tell they're more distant stars because they don't friggin' move in the picture. From that, you know how big the orbit of the Earth is, and you're able to figure out how far away that star is. I guess it has to do with light because you are measuring light. You're taking a picture of it, but to me, it's not information that's actually carried in the light.
In the light, yeah.
Yeah, it's just kind of an optical thing. And so you can do it with your thumb.
Yeah, isn't it like when you switch your eye?
Yep.
And then it's like
Yep.
your thumb appears to move even though
Yep.
you're not moving your thumb at all.
Yeah, and so
But there's distance between your eyeballs, so.
Yeah, so if you hold your thumb out and you look at it with
But
your right
everybody do it
eye.
with us.
Huh?
I said everybody do it with us.
Yep, if you look at it with your right eye, notice where it is. Now look at it with your left eye, notice where it is. It shifted, and technically you could use that shift to measure the length of your arm. You can also figure out which one's your dominant eye with it.
Just by how easy it is to close your eye?
No. And so if I look at my thumb right now, it's right on top of, to me anyway, the camera.
Yeah, you're pretty spot on there. It's pretty good.
Yeah, and so now if I look at it with my right eye, it's still on top of the camera. If I look at it on my left eye, it's off to the left, off to the right. So my right eye is my dominant eye.
Oh.
Yeah. Now look at it with both lights open, both eyes open,
Okay.
and notice where it is.
Well, they both move to the side of the camera.
Okay. All right.
Do I have even?
I guess you got even eyes.
I got even eyes? Is that why I have 20/20 vision?
No.
Oh.
It's completely unrelated,
Okay.
but okay.
My eyes.
Because I don't have
They
20/20
are
vision in my
both
right eyes.
dominant because they're 20/20.
Okay, yeah.
Which means
sure.
I should have good hindsight.
What? You should
have good hindsight because I have 20/20 vision
Oh,
and
but-
hindsight is 20/20.
Yeah, but we all have good hindsight. Hindsight is always 20/20.
Oh, I get it now.
Yeah.
Oh.
All right, but these
I should have good foresight. Anyway.
Yeah,
okay.
actually.
Yeah.
Okay, so these couple of things you can actually use to measure the size of the universe. Cepheid variables.
Cepheid variables.
From the constellation of Cepheus, the king. Wow. We still got it. Henrietta Swan Leavitt in 1908 discovered.
We had a shot
on her, I think. If not,
we talked
should.
about her.
Yes. If not, we should make a shot on her. In 1908, she discovered a relationship between. Cepheid variables are these stars that will brighten and dim, and that brightening and dimming is proportional.
Are these the standard candles?
This is a standard candle. It's always the same. And so you can use it to, that brightness, all Cepheid variables, well, there's two, short-term, long-term, but they will all brighten and dim the same way. And they will always reach the same brightness and always the same dimness. And so you can use those, you can use that information to actually figure out how far away that star is. It's like moving a light bulb closer and further from you. And so Edwin Hubble used it to figure out how far Andromeda was and to settle the great debate.
Yes. Which, check out that shot episode on Hubble. Edwin Hubble.
Yes. So.
Up now.
However, though, recently.
Or on Wednesday.
With Spitzer. May Spitzer rest in peace. They might not be as standard as we thought. Because some of them, 25% of them lose mass.
Oh, so is all of our distance
It could be
wrong?
Could be.
So we possibly don't really know how far away anything is.
Well, if Cepheid variables were our only tool that we use.
Oh, but they're not.
But they're not.
Ho ho ho! Science.
I think I just nailed the camera. I apologize for that.
That's fine.
Related to Cepheid variables are RR Lyra stars. They are also
In the
variable
constellation
stars.
of Lyra.
In fact, named after the RR star.
Oh, okay.
Yeah. These two are Cepheid variables, but they are dim compared to. I'm sorry. These two are variable stars, but they are dim compared to Cepheid variables. But you can use them to tell how far something is. The thing is these tend to be stars that have ages typically around 10 billion years old.
Oh, so
they're very old. So they're generally found in globular clusters or in the bulges of galaxies, and so you typically use them only to measure distance to globular clusters. But it's still
limited use.
It is limited use because Cepheid variables are better.
And by the way, globular clusters are basically globs of stars, large star clusters that are hanging out, orbiting in the halo of a spiral galaxy, kind of outside of the disk and.
Yep.
Yeah.
Yeah, and actually, if you can find an RR Lyra star in, like, say, the Andromeda Galaxy's globular clusters, and you know exactly how far away that is, and like that. And so, it's a good way to test, distances and stuff.
Yeah, well, I mean, it's a good idea. Obviously, in science, we want to have different ways to. Different methods and different things to go by in order to figure out all that shit. Is you put the iPad away? Is that all?
There's only one more.
There's only one more?
There's only one more.
All right.
And that are Type 1a supernovae.
Oh, yeah.
Type 2
Like Cassiopeia A.
Yeah, Type 2 supernovae are where a star says, I'm done, and blows up.
Peace.
I'm out.
It's like smoke bomb.
Yes. Except doesn't quite disappear, but there is a... Type 1a supernovae are supernovae where a white dwarf explodes in a supernova explosion, and basically there's about 1,000 per year of Type 1a supernovae. They always brighten and dim in the exact same way, and you can use those brightness curves to figure out exactly how far a galaxy is. These supernovae, you can see them across the universe is what you can do, because they outshine the galaxy. They outshine the amount of energy that our sun produces in its entire lifetime. So these are very bright events, and so you can.
Do they shine like a diamond?
For a bit until they don't. And we used to think that we had a pretty good understanding of what actually forms a Type 1a.
We used to think.
Yeah, and so what they thought happened was that a white dwarf would pull off material from another star, and so that would accrete onto the white dwarf. It would get to a certain thickness, which is going to equate to a certain amount of heat, and that mass.
It just can't handle it. It can't handle
It just
heat.
can't handle it, and it actually creates this runaway thermonuclear explosion, which destroys the white dwarf and creates the neutron star. It creates the Type 1a supernovae. And then I think in 2018, this weird one happened, and so
A weird one
happened, which wasn't quite what they were expecting, and so
they're like, uh-oh.
yeah, and
okay.
so there were some astronomers who set about trying to figure out what was causing the issue. I mean, what was causing what they saw, and they came up with the idea of really what was going on was you had a a white dwarf. I don't know why I want to keep saying neutron star, but a white dwarf that was orbiting another white dwarf, and that the one white dwarf
was able to pull
A,
enough to.
Yeah, and so white dwarf A was stealing helium off of the other white dwarf.
White dwarf B.
Yeah, white dwarf B. And of course it exploded in this Type 1a supernovae, which then basically you have lost half your mass in the system, and it makes the other white dwarf just go careening out into the universe. These high-speed runaway white dwarfs. And so
runaway white dwarfs.
Yeah, and so the astronomers were like, okay, here's the thing. If this is actually what's happening, then and this type of situation perfectly showed
how we don't know jack shit about the universe.
Well, that too, but it perfectly showed a light curve that they had witnessed for this weird Type 1a supernovae explosion, and so what they said was, what you should find is either 0 runaway high-speed white dwarfs, or you should find them. And astronomers found 3, which isn't a high number, but it's also not 0.
You should find 0 or you
a
should
billion.
You should find
0 or a billion.
we found 3.
And they found 3. Well, I mean, 1,000 of them happen every year, and so you should be able to. I mean, but these are
Find
kind of dim.
some that are runaway.
Yeah, and so like Tom Petty, Runaway. But anyway, but they found 3, and so now they're not entirely sure. And so, but in the end, that's just the process that creates the Type 1a supernovae.
Wow.
It still reacts the same way, and so
Okay,
there's
so
still a good standard candle. It's just that we don't understand the mechanism necessarily.
Yeah.
Kind of cool.
Wow.
That's a very long-winded how we measure the universe, from how things are, what they're made of, to the temperatures, to kind of getting the size of things. And the universe is huge. Mm-hmm. It's insane that we're able to figure out how far away things are. Oh, and also I didn't even talk about this. Just the Doppler effect of light.
Redshift, blue shift?
Redshift, blue shift. Hubbles constant. You're able to look at how fast something is moving away from us, galaxy-wise, and you're like, you can tell how far away that is because of Hubble's constant.
Shifts more toward the red, and it's the same It's not like it turns red or it is red or anything. It shifts just more to the red as it moves away from us, and then shifts more into the blue as it comes towards us. And the amount of shift, then we can determine how fast that rate of shift is.
Exactly.
Like
and,
sound.
And because the universe is expanding at a certain rate, you're able to figure out, okay, because this galaxy has this particular redshift, we know exactly how far away it is. Which means you need to understand what's called the Hubble's constant, get a really good value for the Hubble's constant.
And just math. You need to understand math.
You do have to understand
Gotta understand some math out there.
Doesn't work for all galaxies. The Andromeda Galaxy is heading towards us right now. But it's close.
It's coming towards us, and guess what? It's not going away.
No, in 5 billion years, it's gonna hit. It's gonna hit. It's gonna bam, 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 bam.
We're gonna merge. We're gonna do a little dance. We're gonna do a dance.
We're gonna do a dance first.
Many millions.
Many years. What we'll do is we'll swing past each other first, and then we'll merge.
Well, yeah.
So it's a dance.
It's a dance.
It's gonna be a beautiful dance.
We're gonna dance. You can dance if you want to. You can leave those
safety dance
galaxies behind.
We can dance.
You can
We can
galactic
dance.
cannibalize or merge together. I don't know.
Oh.
And meanwhile, when you were talking about
Safe
runaway
dance.
white dwarfs, I was going, run away every now and then. I'm just a little white dwarf stealing material from my binary partner.
Oh, that's good.
Run away.
That's actually really good. All right.
That was good. That was good times. I still don't know. I don't know. It's how we understand things still. By the way, where's the Skittles?
There are.
How do we measure stuff in space with Skittles? Do we want to say Skittles for the hangover?
Well, I did tell you I didn't do any calculations.
I thought you did calculations.
I did one calculation that would tell you how many Skittles it is between here and Melbourne, Australia, because Brandon asked. All right, so but then I was like, oh my God, I didn't do any Skittle calculations. But there are, 1.3606 billion Skittles between here and Melbourne, Australia.
So either we use light to measure the universe, or we can taste the rainbow with Skittles.
Exactly. And with that...
Light is a rainbow.
Light
So
is a rainbow.
Skittles.
Oh, yeah.
Mm-hmm.
Yeah.
Skittles are light.
Skittles are light.
Skittles are the key to the universe.
We
should be sponsored by Skittles.
Are
but
all
we're
the
not.
are all the gay haters not eating
Haters.
Skittles? Do they?
They don't. Yeah. Do homophobes taste the rainbow?
I really want them to, just because of.
These are the burning questions we ask on Cosmos with Cosmos.
All right. We will not be with you next week because we will be moving.
We will be moving.
And so this does not interfere with other plans that we have later in the summer, in particular with Katie's birthday and a NoFX concert that we're going to go see. We are going to come back to you in 3 weeks.
So on the 21st?
On the 21st is when our next episode will be. It will be a High in the Sky episode.
Again.
Do we want to do like gay High in the Sky then? Because that's going to go out in June, right?
Because we'll have one in June.
Okay.
So.
I mean, it's going to be mid-June, but that works.
Yeah. So
All
we'll
right.
do. Well, in June, we'll get gay in June.
All right. So, so we'll see everybody on May 21st, right?
Is that what I just said? Because I
I
put the
think
calendar
so.
away and I already forgot. Hold on.
I think it's May 21st. And
May 21st. May 21st.
right, because
Cinco de 21st.
I want to be eating these butter chocolate chip cookies.
Oh my God. Brown
and
sugar chocolate chip cookies?
Yeah, brown butter chocolate chip
chip
cookies on Memorial Day weekend. And I don't want to be dealing with this.
All right,
Cosmos with
fair
Cosmos.
enough.
Well, no, because Katie's gonna be at our
I
house.
know.
All right. So anyway,
Now
we'll
she's
cut all
committed.
this out. This is all gonna be cut out. So
Is
cheers,
it?
everybody.
It might be.
Stay safe. Stay healthy. Stick around because we are going to be having the hangover. Who knows what we're gonna talk about? So we'll see everybody in a few minutes, or we won't.
Otherwise, bye.
All right. Cheers.
All right, everybody. We'll be right back with the hangover. So, Why does my iPad keep turning off? God, it's my whole. I need a
New iPad?
I need a Stream Deck is what I need right here. So stick around.
Do we need that as a housewarming gift?
No, we don't need that. Anyway, now we'll be right back.
Cheers. Man, hey!
And we're back with the hangover. And Mike just said to me 1 second ago, man, that drink just hit me.
It really did.
It's an appropriate time for the hangover.
Yeah. Or is it?
Well, did you have some of your cheese?
Huh?
Did you have some of your cheese?
I had one at the beginning. I guess I'll eat some now.
We got some cheese just to,
Well, I guess it's going to do any good.
That's why I had some leftover pizza earlier. It was good pizza, too.
I think for me, it was just that I had it too long ago.
Yeah.
I had it for breakfast because I couldn't find breakfast for dinner.
It's probably in the fridge.
It is. I found it
You
when I
forgot-
was
you
getting your
forget
stuff.
You forget about
No.
the fridge.
No, I went there.
The garage fridge.
The garage fridge, and what I did, I didn't open up the bottom drawer, and that's where it is.
Oh.
And so it was hidden up underneath, like the Paloma mix that you are now enjoying.
Okay.
So, yeah, I mean, Palomas are really quite refreshing. I'm not a tequila fan, but
Yeah, I'm not a big tequila person either.
but
so.
but that was because it made me so sick one time.
I think everybody, or a lot of people have that like one bad experience with alcohol in their youth. At some point in their youth, that then they are like, I can't.
So I had gone. I worked in a planetarium.
You worked in a planetarium?
I did.
What?
I did. I worked at a planetarium,
This is
and there was a guy in high school. I guess he had gone to the planetarium. He remembered me. I did not remember him. Now, in my defense, though, we had 700 people that I graduated with. There were like 2,500 people that went to my high school.
Yeah, I had a similar high school population.
And I was like, oh my God.
Hold on, I just realized that I forgot to put the chat link into OBS here. So you tell your story while
Okay, and so he invited me to go see him play. He was in a band. And he invited me to go see him play. And so I went with a friend and his girlfriend. I felt like the biggest third wheel ever. But this was a friend of mine that was in my French class.
Oh, parlez-vous français?
Yeah, I forgot everything. I took that class over a summer. Both semesters over a summer.
Deux, trois.
Yeah, and proceeded to forget everything as soon as I walked out of the final exam. I got a
Donde están los zapatos?
I think I got a B in the class, which was really all I cared about. So,
And for Federico, buongiorno.
Yeah. And so I had gone with this friend of mine
Oh my god, I love Valentine's Heart.
to see the show, and we decided, hey, let's do half tequila shot. So half tequila, throw a little Coke on it, and Coca-Cola, not cocaine.
Just sprinkle a little.
Sprinkle a little cocaine on it.
I
Well,
don't think
half
you're supposed to drink
half shots turned to full shots.
Uh-oh.
And it just destroyed
you?
me. And I had to go give shows the next day.
Oof.
And it was a lot of
Hungover in a spinning dome. Not
yes,
Good. Not good.
and spinning stars without looking at stars and not giving a fuck where those stars ended up. Because there were like, and this was actually my idea. I don't know why people didn't do this, but so you would have this is an old school planetarium, and we would have the script. You'd follow the script. it's just a narration, so you're just following it. But to the side of it, you would have the visual cues. This is what you want to bring up. This is how you want to, you want to bring up stars here. But there were a few where it was called mid-screen. There were a few where you actually had to land the stars at a certain spot, so certain things would come up and it would be, it would make sense. And I was just like, how come you guys don't put the speed at which to rotate the stars to tell you exactly how fast to move the stars so that they end up where they're supposed to end up?
Yeah.
And so I actually had worked out the speed for all of them, and we had put a little glow in the dark like little thing on the dial, so it would tell you. And I was like, you just do it at 2:00, and this is the speed you need. And I didn't care in that show, though. I didn't care if they ended up where they were supposed to end up, because I mean, I was better by the end of the day. But
And what lesson did you learn from it?
to not drink tequila. It was, oh my God, at least not to the extent that I did. So, I don't even remember what genre they played. My cousin had a band. He was a metal band.
Oh.
So, but and I saw him play. But yeah. Anyway,
Well, cool.
anything you want to talk about
Um,
specifically?
no, not specifically.
I just think, like I told you earlier today, like the craziest thing that I think about when it comes to physics is we don't really touch each other. I just find that just absolutely fascinating.
But we feel, though.
We feel that's because our neurons in our body are actually feeling the pressure.
The pressure against...
Yeah, but we don't touch each other. And so
Electrons,
it's basically, yeah. So it's feeling the repulsion of your electrons with my electrons. You do because you actually are, we have
this
enough.
This has different electrons than this
Well, it has a different
pattern?
Pattern, yes, exactly. It has a different pattern of the material. And so we have so many neurons in our body that we're able to actually, figure out, like how much of this shirt is touching my skin, and is it annoying because I have a sunburn or something like that. And so,
but it's not actually ever...
No, it's hovering. It's
are
hovering over.
Are you actually touching you? Are you
No, if I go like this, I don't actually
is your
touch each
skin
other.
actually touching your muscle? And your
Well, see, that's different though, because you do
muscle
have
touching your bone?
you do have bonds between different atoms in your body, but I don't have a bond to your atoms in your body, and so it's just all. I know it's just all my electrons pushing against your electrons, and we push. I mean, if we did touch each other and they bonded, we'd really be stuck. No, the question is, are we actually solid? The answer is really no. There's more empty space in us than, because if you look at it,
some
if you
people
look at,
more than others, am I right?
yeah, I mean, if you look at an atom, you have the nucleus. The electron, compared to how big that nucleus is really friggin' far away. An atom is essentially empty. It's essentially empty, and so we're mainly empty. We just have so many atoms in us that we look like we're solid, but we're more empty than we are solid. It fucks with your mind, doesn't it?
You know what? I think that everything, the whole, and this is maybe why people are like, I'm just gonna stick to believing in Magic Skyman, because when you are not someone, I don't know, even if you're studying these things in depth, it's hard to if you think too long or too deeply about it, it gets real.
Yeah,
It gets real.
and
wait.
quantum physics
What's
people.
happening?
Quantum physics people will tell you.
Trying to fill the void with chocolate cake and booze. Yeah, or some of that pistachio cocoa.
Oh, I need to go for chocolate cake now. But like quantum physicists will tell you that if you say that you understand quantum physics, you don't. Even like
Nobody understands.
even like Nobel laureates who have gotten their Nobel their Nobel prizes in physics.
So like we don't really get
for
it.
quantum.
The
No,
math,
like we don't get it.
Look, the math works, but trying to maybe it's trying to think about it with our trying to with our human logic going into it. It's like we can't.
You can't do it
because it's such like a.
Well,
it's nothing we can relate to. We can't relate like the distances in space. We can't relate to those
nice
distances.
segue. I was gonna do it, but
we can't relate to those distances at all because they're not something we experience in our daily lives or can comprehend. Because.
So, I was talking to my parents today, and my daughter is graduating on the 11th.
I wasn't touching you.
No, you weren't. Technically, you weren't. She is graduating with a physical therapy degree on the 11th.
She won't be touching anyone.
No, she won't. It really is a summer thing, And so I'm going to go see her walk across the stage. And I was telling my parents about how it really freaks me out. This getting on a plane, going from Eugene, Oregon to Phoenix. It really freaks me out. And I'm going to be wearing a mask the entire time. And I'm one of these people where I just can't get sick because I really do. There's the possibility that an infection might really just mess me up, and not in a way that I want to happen. And so,
is there a way where you would want it to happen?
No, but true. But this trip really does worry me. And I told my parents I had even contemplated driving down there, but it's 1,200 miles, and I can't do that either.
You gotta get a K95 mask. I think my mom said she had one.
Yeah. Where was I going with this?
I don't know. You were worried. You're telling your parents you were scared of going on the plane because you can't get sick, but you're going. I don't. You started it.
I did start it.
I'm just telling you where you were.
It actually was friggin' related
to the space distances. And understand.
Oh, yeah. No. Okay. So, thank you.
Yeah, that's what I'm here for.
1,200 miles is a distance I can understand. 3,000 miles is a distance that I can understand because I've driven it. Flying 10,000 miles, 12,000 miles, whatever it is, to Auckland, New Zealand is that I don't understand. I got on a plane and I woke up and I was in Auckland, New Zealand.
You were in Middle Earth.
I was in Middle Earth.
Out of nowhere, you were in Middle Earth.
Yeah.
I'm gonna count that because we haven't had a lot of drink purposes. So.
Do we need a lot of them? I mean, I guess it helps, but. And so, when we start talking about astronomical distances, though, it quickly blows your mind. 250,000 miles to the moon. None of us can relate to that.
No.
We can't relate to that.
I mean, we could just throw a lasso around the moon and bring it right here if we want.
I really love the Wonderful Life reference. Very good. That is really good. Yeah. And yeah, Jack wears a 95. It just really it scares the hell out of me right now. But anyway, these astronomical distances, you don't have to go far to where you just can't relate to it or understand it. Distance from here to the moon, 250,000 miles. None of us understand that except for Buzz Aldrin and the remaining astronauts that walked on the moon.
There's
or that went to the moon.
There's like 13 people that understand that distance.
Yeah, and You know, and so now the closest star to us, 93 million miles. That's a long way that we cannot comprehend. Now, when we start talking about other stars, we don't even talk miles.
Especially when you think about, like, our sun is a star, fact. But then at night, and you look and go, these stars are just like our sun, but they're, like, you can't even look at our sun directly because you'll be blinded, you know, because it is so close to us. Yet, at the same time, it's so incredibly far away from us, from our own, from how we relate to distances. And then you think about those other stars that miles becomes just too many zeros and a too big number that we have to then make up distances, we have to make up units of measurement just to handle these immense distances that we can't actually comprehend.
Yeah, and people still don't even understand those, and it's just like, okay, so the closest star to our sun is 4.3 light years away. Now we have completely changed units of distance. And we have picked this really weird,
confusing
measurement
where we turned a distance into time. Yet it's not a time at all.
Yeah, it's how far light travels in a year, which is roughly 7 trillion miles or something like that. And
6 points.
Yeah, and you can't comprehend it. And then you even go further where light years don't make...
Where astronomical... parsecs.
Yeah, and then so you switch from light years to parsecs, which is something like 3.26 light years.
Which is a distance and not a time, so you can't do the Kessel Run in 12 parsecs, because it's not a time.
Exactly, and parsecs is related to parallax.
Sorry, guys.
Damn, I missed it.
That was... No, Mom. There is no up, technically.
Do I have to do another drink?
No.
Okay.
There's no up in space.
No, and what is up to us is down to...
Australians.
Exactly. That's exactly what I was going to say. It's all...
Is Brandon upside down right now?
Brandon, from our perspective, he is upside down, and not only that, he's flying upside down. His plane is upside down. But, I mean, it's just it's mind-boggling that, I mean, it really, your brain just kind of shuts down at some point, and I do understand, in a way, people just throwing their hands up, and evoking the god of the gaps of these things, and
it's too hard. My brain hurts.
It makes no sense to me. It's easier for me to do, just give up. But when you really do start thinking about things, it's fascinating. And just don't even worry about the quantum side of things. Just the universe is immense. And you start thinking about these distances, and it's crazy. Sure, it blows your mind, but we're able to measure these things that are 13 billion light years away. And you know what is even more mind-boggling is that, so we see this thing that's 13 billion, we say it's 13 billion light years away. It's not really 13 billion light. It's like 100 billion light years away, because the universe has expanded and it's taken it with it, and it's taking us away from it. And so the universe, it's not really 13 billion light years away.
No.
It's really like it. They don't even really know how big the universe is, but it's at least 80 billion light years away. That separate us now. When the light left that object, sure, 13 billion. But now, because of the expansion of the universe, we're actually much further than that, 80 billion light years away. And that's assuming just a regular constant expansion.
Rate of expansion.
Yeah, it's not even.
Which why wouldn't the rate of expansion be constant?
The dark energy.
Well, I mean, the dark energy is what's causing the expansion, yeah?
No.
Oh.
No. We knew of the expansion prior. It's just, whoa, you're gonna hit the microphone. It was the Big Bang. It's the explosion that's shooting everything out.
Well, yeah, but dark energy is causing it to continue to.
No, the dark energy is causing it to accelerate.
Yeah, that's what I meant.
Yeah.
Accelerate and expansion.
Yeah, and so that the Hubble's constant, which measures the rate of expansion, is going to be increasing.
I guess I meant to say like the accelerated rate of expansion is constant.
No,
it's constantly accelerating.
well, okay, I say no as if I have some sort of real deep fundamental understanding of dark energy.
Why not? You're a fancy physics man.
But nobody understands what dark energy is.
No, because we don't know what it is.
And so the prevailing theory is that, the prevailing idea is that it should continue to accelerate. It's not necessarily a constant acceleration.
How fast will it get?
42
All right.
dark energy acceleration units. It's always going to be 42.
42 dark energy acceleration units.
All
right.
So I throw 42
DEUs,
out.
42 DEUs.
I throw 42 out when I don't know the answer. There's going to be a day where 42 really is the answer. And
it's always the answer.
It's always the answer, 42. Yeah, and that's why they're saying that the possibility with dark energy is you got the great rip, the big rip.
Oh, right, yeah.
It just rips the fabric of space and time.
What would that do to us? Would we feel it? If it happened like
Probably.
tomorrow. If it happened tomorrow and the universe ripped apart.
Oh, well.
Just be like, it's cool.
Well, so if you're standing next to a bomb that explodes, do you feel the bomb that explodes? Is it like just a moment where you feel something? How close are
you to the bomb?
It explodes right next to you.
Oh, is that how it would be?
Well, if it happens tomorrow where you're ripped apart, that's a tough question. Is it like an instantaneous rip, or is it like you're falling into a black hole where you're like, oh, this is comfortable for a second, and then you get ripped apart, and then it's not.
The ultimate medieval stretching torture device.
Yeah, really.
Spaghettification. Maybe they knew about spaghettification in medieval times, and that was the actual
they were trying to make it
idea for the stretcher, whatever it's called.
So your mom was saying, I don't think I'm going to be able to get any more height. She told me this yesterday, which none of us can.
Taller?
Yeah,
no,
it actually did make sense to the conversation that we were having. I don't remember what the conversation was. It was either yesterday or the day before. And really and truly, a black hole can take care of that. Make all of us taller. I am 1 inch from 6 foot, and I really want that 1 inch, and I'll never have it. I just need to go to a black hole and stretch me.
That's right. I don't know why, for some reason, my brain goes, 5'11", and then 5'12", and then it's 6 feet, when 5'12" is 6 feet. Because you can't have a 5'12".
No. I don't remember. Oh, God. I don't know if it was on TV or whatever it was, but there was somebody, they were asked their height. I think you probably have more.
You think so?
Yeah. You have more?
I do.
They were asked how tall they were, and they said 5'13", which is a very valid statement. It is very valid. But I had to think about that for a second.
We were watching that.
Yes!
We were watching whatever that was, and we were
like... It was like 5'13".
And we were
so
like,
you're 6'1"?
We were like, wait a minute. What?
Which is a really valid way of saying it.
Why would you say 5'13"?
I really... Okay, so you and I are going to get our our Oregon driver's licenses. It asks how tall you are, and I really want to say 4'23".
4 feet 23 inches.
I'm 4 foot 23 inches. And just let them figure it out from there.
Does that make me 63 and a half inches?
What? What'd you say?
63 and a half inches.
That makes...
Am I 60 inches is 5 feet, right?
Yeah.
So I'd be 63,
so you're 63.
3 and a half inches.
Mm-hmm. And actually, on the thing I had to fill out, it did say, it did separate feet and inches. And I should have put 0 feet and then however many inches it is.
I wonder if they would catch that, or if they just would not catch it and then print it on your license. That would be funny though, to like purposely like get pulled over, just so you can have the police officer look at it and be like, wait a minute. See if anybody notices.
Just so that it just says 71 inches.
And see if anybody notices when they look at it, your height.
Oh, that would be awesome.
That'd be funny.
Oh, God, can I change my thing now? I want to change it. I want to go back and...
I'm sure, I mean, it's not like you submitted anything, right?
I did. There was like a little form that you could fill out that is supposed to expedite stuff, and so I did do that. Damn it! But I printed it off.
Oh, I thought that was just like a checklist of things.
No. There was a thing that there was a rabbit hole. I guess I went down. So 6 foot 12 inches.
You were 6 foot
So
12 inches,
7 feet. I just really thought that was funny that when we did see the guy go on 5'13".
That's right, and we were like, took us a second to be like, wait
which
a
is
minute.
a very valid way of saying 6'1".
Yes, it is, but at the same time,
Oh my God.
I mean,
So last week we delved into politics because of the alcohol. Now we're diving into how tall we are because of the
into
alcohol.
heights. Well, at least it fits with the theme of the show, which is measurements, which are all arbitrary anyway, because we just make them all up.
Yeah, it's so stupid. All right, in Iowa
saved
last
your
year, my
license.
height was pulled from my passport, and I was 30 pounds heavy. Oh, well,
Hey.
okay. Then I'm going to be 30 pounds heavier if they pull it from my passport here in Oregon. Oh, they stamp your license, smartass.
Watch out, known smart ass. They put that in the database. We got a smart ass on our hands. We got a smart Alec.
You wanted us to move to Oregon, so you got
So here we are.
the smartasses have arrived. Utah is so happy to have us gone.
There was something this is not really related, but related,
This
but
is
not
a
really
hangover.
related. It's true. I saw something on Twitter that somebody posted that it was like basically like a conversation between, if you had a conversation between Tig Notaro's Star Trek character and Captain Shaw, and just the fucking sarcasm battle, the witty sarcasm that would ensue between those two.
They really
Characters would be.
They really are two of my favorite characters. They really are, and I do love sarcasm. Sarcasm is an art.
Especially just a dry, sarcastic
Yes.
humor.
It
is
really-
great. Just a deadpan
Yes.
sarcasm.
Sarcasm is an art, and I know that middle schoolers think that they have mastered it, but they haven't. And
We taught him how as a pro.
Tig and Shaw have completely mastered it, and it's a beautiful
It's
thing.
funny, I don't remember Tig's character's name in Star Trek, but I don't know the actor's name who played Captain
Yeah,
Shaw.
and but we can visualize them, right? Yeah.
Since we moved, Jack's been sent 3 buy land in Utah. Well, now you can buy land in Oregon, Jack. Come up to Oak Ridge. It's beautiful.
Actually, you can move right next to us. Actually,
Yeah, there's an open plot for sale. We would be okay if you built on that land next to us, Jack.
yes, and then,
But I don't think it's as much land as you would probably be looking for or want. Since it's just
No.
like probably a quarter of an acre. But
Yeah, it's not. But I mean, we are so excited to get to a place where we could put something wrong with my ear. You were staring at it.
no.
Where we could possibly see the Milky Way.
Yes.
I even bought a green laser.
You did buy a green laser pointer that comes in a tactical case.
which is so weird. But to be
And it
honest,
also has a little party effect on it.
it did.
Filter.
And that little thing, which actually breaks the laser up into like a party effect, was screwed in. I was so confused, and I was so disappointed.
Like, no, I don't want to.
I don't want
I don't
this.
want this.
Until I was able to remove it. But I got it so that we could point things out really and truly to your mom in a dark location. Or really even here. I just want to be able to show, like, hey, this is what we're looking at right here.
Jack says he's hoping Shaw's character comes back as the emergency engineering hologram. reverse your own polarity.
Well, okay. Have you seen it, Jack?
Well, he says comes back, so he knows
yeah.
it. We won't. Well, I don't know. Well,
Okay, if you haven't seen it, you're not a true.
Also, too late. I mean, come on, you've had plenty of time.
You've
Well,
had
no,
plenty of
but
time.
Brandon hasn't had time to watch it.
I don't care. He's not watching.
I know he's on a plane right now.
He's on a plane. But it is. Oh, the feels you get it. Just to be honest, just the feels you get just seeing them back together. And
I don't care the last season of Picard is just Next Generation, the final episode.
It's just feels,
and I'm okay with that, 100%.
Yeah, and I've read complaints about the season, about the last episode, and things like that. And to me, it's not what it's about. It was all really about them coming together, and it was they played poker in the end, and it felt like we were part of that poker game. And
It was good.
And so this is the Star Trek of my youth. I did watch the original. Okay, it was in rerun. Let me preface that. It was in rerun. But I did watch the original Star Trek with my dad. It would come on every day, and we would sit down and we would watch it. And so my dad introduced me, to Star Trek and also to Star Wars. When I was a little kid, he was like, hey, there's this great movie called Star Wars coming out in about 6 months. We're going to go see it. And he took me to see it to the Dutch Square movie theater. And I saw Star Wars there, and it was just an amazing thing. But the Next Generation, that's my Star Trek. And to me, it's a very cerebral Star Trek. It just gets really good at the end. They figure out who they are, and it's just, it really is like, it makes you think. And it's great. It's great.
Yeah, it was coming together to celebrate Troy finally getting her pilot's license.
What was the there were episodes where she was, looking to become the commander on, like, it was basically the Night's Watch, but yeah.
When they finally switched her into an actual uniform versus
into the miniskirt, from the miniskirt
versus the her counselor's outfit.
It's like, were they trying to just continue on from the originals? And that's probably what it was.
Maybe a little bit, and then
yeah,
it was nice seeing them all. But it's weird watching. It's weird seeing them now, because obviously, everybody has aged, not in a bad way. But when I see them, it's like I see them now, but then it's like both their younger selves and their current selves are like the same to me. So it's like when they do we don't see the age. When they do show like the flashback scene of like, they'll show like Picard younger as Locutus or
as
whatever,
the Borg, yeah.
Or they'll show those kind of those flashback scenes, and I'm just like, I'm like, it's the same, even though, I don't know, it was nice to have that kind of, that final reunion with everybody, and
yeah,
just
it allows
that last,
us,
like, kind of feels with Next Generation, with all that, the new Star Trek that are out.
Yeah, Denise Crosby as Troy would. Yeah, no.
It was nice they brought up Tasha though. They
What?
brought up Tasha
Yes,
with
no.
Data, and they showed that.
I mean, it really
They had some
did.
nice little throwbacks to like Moriarty
It
coming
really
in,
did
and
throw. I mean, it was a feels thing,
It
and
was all
and
about the
and
feels.
it was. This is what we needed
Mm-hmm.
when we were so excited that there was a Picard series, and at the end, I mean, the whole time you're wanting them to bring everybody
yeah,
in.
you just want to see everybody.
And
That's all you
so
want,
this
really.
season, the final season of Picard was all about that,
Mm-hmm.
and and now I'm looking forward to Strange Worlds, and
Strange New Worlds. Is
Strange New
fantastic.
Worlds,
That's
and
in June.
wow, Discovery's next year, right?
Discovery, final series Discovery's next year. But Strange New Worlds is fantastic.
It's really good.
Really well done. I hope the second season keeps the same kind of feeling.
Oh,
and
you know they
everything of
will.
The first season.
You know they will.
And then Lower Decks. Lower Decks is coming back pretty soon, and that's just
Your mom won't watch
That's just
that, I'm
fun.
sure.
that's just fun.
Yeah, that's irreverent, and it's just great. That's a lot of fun. That's that Star Trek not taking itself seriously.
I don't think there has been a Star Trek that's been not like good or true to even the Orville, which wasn't a Star Trek and was supposed to be a parody on Star Trek, turned into like a real Star Trek series where it had
Is
the
it-
same
is that
kind of
canceled?
morals and feelings. I don't know.
Because
I know it's on
that is, to me, Orville's a love letter to Star Trek.
when it was supposed to be just like kind of a comedy, when really it's a love letter and turned into
really is a love
it turned
letter.
into an actual Star Trek versus just
Yeah,
having
and
this parody
and,
element
and
to
I
it.
would love Orville to come back if it. You know what? Netflix picked it up. Did they? I hope they didn't cancel it. You know, maybe Seth MacFarlane is taking his sweet ass time with it, but I really loved Orville. Really loved it. Might have to go back and watch it, but yeah. And then you have all the Star Wars stuff that's going on, and I'm not really sure. I still haven't decided if like Disney has diluted it a little too much, but like I like Mandalorian. Mandalorian, I thought this last season was great.
I thought it was good. I mean, it was fun and everything. I don't feel like I think it went a little on the like the first season of Mandalorian. It had a real kind of just, I don't know. It was something really like it was like an artsy and like
like very
really just
Western.
kind of like unique cadence to it and everything. And I think this last season it went a little bit more mainstream with, kind of a little bit more hokey and cliche. And but it was entertaining and fun and I enjoyed it, but it didn't have I didn't feel like it had like the uniqueness like the first season had to it.
Yeah,
in
what I
terms
really
of-
like, my favorite right now with all of the Star Wars stuff is Bad Batch.
Yeah,
I really
Bad
like
Batch
Bad
is-
Batch. Yeah, and it's just you like with Wrecker in Bad Batch, you just kind of fall in love with him because I mean he's a wrecking ball,
and a teddy bear.
but he is such a teddy bear with Omega, and it's just
We have to finish Andor because I know that Andor is supposed to be really good.
yeah. We only watched one episode.
Yeah.
I think it was Star Wars Overload at that point, and
Yeah.
and the first episode I don't think necessarily just really kind of pulled us in. Yeah, so Almost Australian is also another episode thing you need to watch, which is not Star Wars related at all.
Wow, way to.
Well,
In this
since
part of the
we're- since we're
hangover,
talking
we
about-
go not politic and we just talk about the shit we're watching.
Okay, so I really felt like last time I went down an angry politics rabbit hole.
Now we're just going to talk about things we love.
Right, and so this time I really did try to make it so that I would not talk about politics, even though there's a lot of things that really do make me angry right now, and I just want to beat my head on the wall. But there's also a lot of just amazingly great things to life. And these stories that are told, whether they're Star Trek or Star Wars.
Celebrating different things, different people, different ways of thought. Like the Almost Australian you reference, which is something we just discovered on Netflix. It's from like 2020, and it's an actress who was in Harry Potter. She played
Professor Sprout.
Professor Sprout. She's a British woman
who hates kids, ironically.
And she, her partner is Australian, and she got her Australian citizenship, and so it's interesting because it's her kind of traveling through Australia, trying to figure out what it means to be Australian and the Australian dream, and she's encountering different people in different walks of life, and also she's seeing a side where she never thought about, the Aboriginal or the people who had, are treated basically the same way as Native Americans are here, where they're just kind of shoved out of the way and put in poverty. And so she's looking at that aspect, of it. And I don't know, it's just a really kind of like she's like everybody's grandma, like she's she's had an opinion about something, and then somebody has given her a different viewpoint, and she has apologized. She was like, "Oh, I'm sorry, I did not think of it that way," and she then changed her. And I was like, "That's all it takes."
That's all it takes.
That's all it takes.
That's all it. That's really and truly is all it takes.
It's just like kind of it's an interesting series. That's kind of a way just to kind of look at different people and different ways of thought while they still live in the same country and have different experiences, and just to kind of be a part of that and recognize it and acknowledge it. So it's,
I do think that we all need this.
And that's what Star Trek does too. It's like you're experiencing these different cultures, different species, different ways of life, different languages that then they're trying to then cohabitate with, or to understand and to get along with and to be respectful of, and I think that's just kind of what we all just need.
Yeah, I was really, there was some conversation I think we were having, me, you, and your mom, and I was just like, can't we just get to the Star Trek universe, like now? Can't we just do it? Oh, I remember what it is. I'm not going to bring it up here, but I do remember what it was.
No angry politics.
And so it was, can't we just hurry up and get to the Star Trek universe where...
I just want replicators. I just want to... and anything Jack is drinking that he's made himself, I just want to be like, make me that.
But that has to be uploaded. But then the thing is like...
upload your recipes to the...
But then they have the whole Synthanol thing, and it's just...
Oh, fuck that.
It's... It's alcohol without the effects of alcohol. What's the point of alcohol then?
Yeah.
So let's see. A friend.
Jack says a friend of a friend was a background actor on the first 8 episodes of this season of Picard, and he's a fan and had a great time as well. He wasn't called for episodes 9 and 10. Oh, that sucks. But also, what an amazing opportunity for him to be an extra on any episode of Picard. I mean, just to be in the proximity of Sir Patrick Stewart.
Well, yeah.
I mean, we got our photo taken with Brent Spiner at Salt Lake City.
And that's going to be one of the first things to go on the wall.
Which was phenomenal. And someone that we knew was the MC for his panel, or his talk at FanX, which was really cool. So
but we also got a picture with Gimli.
We got a picture of Gimli. I mean, of course we paid for it, so, and Lucy Lawless, who that was the first time where I decided to be cool around a celebrity, but that was the first, I held it together when we were getting the picture taken, but I was like, oh, I understand these people that go into tears at, like, Bieber concerts or something. I was like, okay, because I walked out of it and I was like, don't cry. Don't cry.
But
she's just a person.
Okay, I'm the first one to say, don't meet your heroes. Never meet your heroes. But if you are at a Comic-Con, meet your heroes. You don't get to really know who your heroes are, on a personal level. But when you get to meet people that just made such an imprint on your life, it really is Yeah, it moves you to tears.
Mm-hmm.
It really does. And if Patrick Stewart, Sir Patrick Stewart, were to walk in here right now, first of all, your mom would tackle him downstairs, which don't do.
No, she wouldn't.
He's a treasure to the world. He's a treasure to the universe.
I mean,
but
she
if he
tackle
did,
Riker.
but if he were to walk up here right now, I would probably just immediately just become a blabbering idiot.
Sir Stewart.
Yeah, I mean, exactly. And like Ian McKellen, Sir Ian McKellen, if he were to walk in here, these are people that you feel like you have such
We'd
a
be like,
bond
oh,
to.
he's arrived precisely when he means to.
Take a drink. Oh man, should we wrap this up?
Mm-hmm.
All right.
Let's
Well,
wrap it.
all right. Well, thank you for spending 2 hours with us today. If you've been with us the entire 2 hours. If not, thanks for joining us for the hangover.
Yeah.
So again, we're gonna be back in about 3 weeks. It's gonna be a high in the sky. We're gonna talk about May 21st.
Oh, Adam, you met Adam Savage? Yeah, that's one too that
Yeah.
his cosplay work is phenomenal.
Yeah.
And his Comic-Con dresses up stuff that he does. Anyway, okay, we'll wrap it up.
All right, so join us in 3 weeks. We're not going to be here next week because we're moving.
And then the following week we'll take a break so we can then get a more consistent schedule going to avoid some other stuff we have coming up.
Yeah, so join us on May 21st. We're wrapping this up on May 21st, and we're going to have a nice little high in the sky where we talk about what you can see in June. Yes.
Yeah.
And then after that, we'll figure out what's up. But the mid-June one is definitely going to be a,
Thanks, Katie. Yeah.
Sky gaze.
Sky gaze. We can't. No, that's probably Cal County has that copyright.
Well, whatever.
All right. Anyway, thanks everybody for joining us.
Cheers, everybody.
We'll see ya.
Bye.
Oh my gosh. Wait, I gotta read these comments.
Oh,
God.
Adam
Man.
coming in. Yes, lift with your legs. I will try to remember to do that. If I come back in 3 weeks and my back is blown out, then you'll know why.
Anyway, all right. Bye, everybody.
Cheers.